we made a water motor, and you might think it's a quaint thing, and it kind of is. And I got it from these model engineers books were published in the late 1800s to the early 1900s, and that's when water motors were really prevalent. Now, it's one thing that never ceases to amaze me is that our worries today are actually strikingly similar to the worries of our forefathers at the turn of 2 centuries ago, which is amazing, really. So they were worried about things like how to power stuff, how to charge batteries, all that sort of stuff. And it's exactly what we're worried about. We're worried about power supply, charging batteries, and maintaining the life that we have in terms of electrical power. So I often think that if we look back to that period of time and have a look at what they were doing, and can that be adaptable to what we're doing now? Water motors were tremendously popular because the pressure, certainly in the UK, water supply at that time, was something like 30 to 40 psi. Now it's somewhere in the region of about 15 to 30 psi, so it's a lower pressure, but not by much. And certainly in my home we have 30 psi, so we have quite an amount of pressure. Now, when you think of hydraulic engines as being things like rams, that sort of stuff, and then hydraulics were thought of mostly as water machines, and there were special hydraulic companies that would supply water with pressures like 800 psi, and they ran motors that were strikingly similar to steam engines. Now, water is incompressible, and so when you close a valve, then you can get a back pressure, the same as in a ram pump. And so you have other things that go on in a water engine, like an expansion tank that's filled with air to take up that compression of the sudden shutting of a valve. But the engines themselves look strikingly similar to steam engines. And they're very old. The first water engine was described in the 1600s of all things. So they're a very old engine with a tremendous history that's very similar to steam engines and petrol engines of today, using nothing more than the head of pressure. I don't use the flow of water as a water wheel would do. They use the pressure of water to run everything. Now, head of pressure is basically weight divided by volume multiplied by the height that the water is sitting at. So you can work out what a head of pressure would be for a given body of water at a given height that would supply you pressure at the point at which you want to apply it in some kind of machine. Now, what became popular, of course, were Pelton wheels. Now, there's lots of Thingiverse Pelton wheels where you can actually print the buckets. You can have a go with spoons if you like, but Pelton wheels, particularly the Thingiverse ones, it's suggested that you print them and then use them as a mould to cast them in metal because they take quite a lot of pressure, and so they need to be quite strongly built. The Tesla turbine, of course, is another awesome option. Again, I think a bit difficult to build, and so the device that we made, which was based on the Whitney motor from the Whitney Motor Company in around 1900 to 1910, was an acceptable middleman. Now, these were advertised as being 1/4 horsepower, which is incredible if you think about it. And I'm not saying what we built was 1/4 horsepower, far from it, but it is an example of how you would go around building a turbine-based water engine. Now, it would be quite a lot of fun, obviously, to build a more steam engine-based type, a little more challenging in terms of engineering, but not that challenging to build these turbine-based types. Now, if you like the Whitney engine, obviously, looking at Tesla and looking at the Pelton wheel would be the next step in producing something that would be able to scavenge energy to a greater or lesser degree. Now, there would of course be the worry about the usage of all of that water, but if you're storing it at a height yourself and then storing it at the lower level yourself for further use, then I don't see the waste there myself. So for instance, as I said on the main video, if you're doing something like filling a bath or filling your toilet, or if you're doing your washing or you're hosing your garden or whatever it is that you're doing, you're taking advantage of the pressure but not wasting the water as a resource. And I think that's actually quite astounding and quite interesting. Now, these things had a huge amount of use. They weren't curiosities, they were particularly widespread. Even when electrical motors came in, because they were quieter, they were simpler, they were cheaper, they were more robust, they were more reliable, they were very low maintenance. They actually went on for a very long time, and the Whitney Company was in existence until the Second World War. So the motors they produced, not only Whitney, other people, did things like the turntables in railways. They used them in the Colosseum. They were used for charging batteries. Miele's first washing machine, actually a water-based motor to run the washing machine. And of course they were used for generating electricity and storing that electricity in batteries. And isn't that one of our big concerns? So I would think a small water motor attached to something, as I did with the NEMA stepper motor, could certainly be an emergency charger run from a saved resource of your own. That's why we went into it a little bit, because it is a little quaint looking back like that, but I often think that a lot of those solutions can be contained in the history if we look at the history as well. So a lot of the times, of course, we're looking at modern developments with things like TENG generators, but it doesn't hurt. In fact, it can be very beneficial to go back on what's been looked at and revisit it, and then maybe update it and think of how it could actually be part of a strategy you might want to use for generation of your own power. Anyway, that's why we did water motors. I thought I would share that with you because they, I think, are far more interesting than we seem to think, and perhaps they're a little bit forgotten. Anyway, I hope you enjoyed the video, and thank you very much for watching.